In order to create the dataset for training or for tests, just as we saw in the last presentation, Carrot also has a special function that allows for this to be done. So it randomly chooses out of our database some observations that are going to go for the dataset for training and other observations that would go for the dataset for validation. So since that's a random process, we also have to use set seed. So it can be reproduced by new users, and I'm going to indicate that it's going to do a partition, and then I'm going to use an object that's called intrain for that, and this carrot function that's called create data partition, and I'm going to show it my response variable. I'm going to do on yield. Usually needs the positions. This works especially fine when we have a response variable that's qualitative. This create data partition tries and do that partition uh, with that's stratified so that there's a proper categorization of the categories and a good representation of those categories in the sample that goes for validation. In this case, we have numerical data, and so it works randomly. I'm going to tell it that I want to maintain a 0.60 of the data for training, and I'm going also tell it that I want those positions to be in a list. Control Enter. If I revise what's in this object, these are the positions that will be for training, and here I can start to drill down my matrix for training and for validation. So I'm going to divide them here. So I'm going to write training. It's equal to, I'm going to put the data matrix, and I'm going to put the positions within train, in comma, to show what are the rows that I want to extract, and this is the matrix. So let's see if I can do it from here. So initially the data matrix has a total of 488 observations. The training would have 295 observations. And now let's build the one for testing. I'm going to write data here, and what I need to tell it is that I don't want those that I selected in the train for the training. So this is the testing, and the testing would have 193 observations. As you can see, the ones that would be in training for this exercise that we just carried out, and they're not going to be in testing. So we've partitioned our database here. Now we can proceed with the normalization. Remember that here we're trying to take the variables of each one of the variables to a scale that's comparable to facilitate the work of the model. We don't have to do this every time, but we want to do it to show you how to do it in the exercise. And because we're going to use random forest, that usually asks for it. So in order to do that normalization process, it's just as we did the dummification process, where we build a model. So we can do it here. So we write normalization. We use this function that's called preprocess that allows us to take those pre-processing steps for the matrix, not only for normalization, but if you go to help, you're going to find more things that can be done as part of the pre-processing. You can remove, you can cut variables that are correlated. So usually I like to do this to know what I'm indicating. So I'm going to use the training data set. This is important. There are things like, or steps like normalization, where it's necessary to use the data set for training and not the whole set of data, because if we use the data object that has the complete database, when we are validating the performance of the model, we would be having a bias on the results that we could generate based on that test data set, because when we were going to use our model with real data, the model never saw those data. It didn't know that they were there. So if we use the validation strategy, if we include our testing in this normalization process, we could be leading to a bias. That's why in this case, I'm just going to use the training for doing that normalization. And based on the parameters of that training, I'll be able to lead my testing to normalization. That's why I'm not going to write here the data object. So I'm going to tell the method that I want to use for normalization is range. And that's from the formula that we saw in the presentation. And it's going to use a scale of zeros and ones for each one of these variables. So this is a model. Now let's use the predict function to do that normalization. Training norm and testing norm. And I'm going to tell it that I want to predict my training matrix based on this normalization. Normalization here. And I'm also going to use the one for testing. Testing normalization, and we're going to see what's going to happen. Well, apparently there's an error here. Oh, there's a problem here. I wrote these parameters the other way around. So first we have to write normalization, and in the end, training. They were inverted. So now we can see in the matrix. Now we can see that these are values that are scaled from 0 to 1. So if we do a summary, the minimum for each one is 0 and the maximum will be 1. And all of these are under one same scale. So now we carried out the normalization process. The next thing is to adjust the parameters. We're going to identify the model, but we could, if we already identified the model, we could also define the parameters that we can test. So in the case of random forest, for example, I could tell it that between the parameters that I'm going to test there, so I'm going to use this function that's called expand grid that allows me to create a data frame where if I have several columns, it's going to show me all possible combinations. So I'm just going to control this parameter. I'm going to tell that I want to use between 3, 5, 15, and 20. Now this parameter for random forest is going to be explored a little bit deeper in future functions. So I'm going to save my script and I'm going to do the training of the model.